For problem set B, in number 8, we have a point xy is randomly chosen inside a square with vertices 0, 0, 0, 6, 6, 6. So let's start graphing those points. We have 0, 0, 0, 6, 6, 6, and 6, 0. So that ends up giving us a large square, about like that. And what is the probability that the point chosen is a y that is less than or equal to this equation? So I'm going to need to put this in a form that is easier to graph. Right now it's in standard form. I want to put it in slope-intercept form. So I just subtracted the 2x from both sides. So now I have y equals mx plus b, well, less than or equal to, where the b is the y-intercept. I'm going to change to red. The b is the y-intercept, and then the slope is the -2. So down 2 to the right 1, down 2 to the right 1. Then when I go to graph this, it's or equal to, so it'll be a solid line. And it'll look like that. So now I have to find all y's below. So I'm focusing on the y-axis and all y's below. So this is the region that I'm looking for. So my total, remember probability, is the win divided by the total. So that would be the area of the triangle over the area of the square. The area of the triangle is 1/2 the base times the height. The area of the square is just the side squared. So the base here is 2, the height here is 4. So 1/2 of 2 is 1 times 4 is 4. And then each of these sides is 6, so that would be 6 squared, or 36, which means I have a 1/9 probability of choosing a point in the yellow region, given that a and b are real numbers, such that a is between, I'm going to do it this way, -4 so that's 1, 2, 3, 4, and 3. And I'm thinking of the x-axis as A, and then the y-axis as B. And then B's, I want my B values to be smaller than 2, but greater than -5. So now, if we look carefully, we can see we've created a quadrilateral right there. And it is 7 by 7. So my total area is 7 squared. And then my winning region. It says, what is the probability that the product AB is negative? Well, in the first quadrant, you're plus plus. In the second, you're negative plus, then negative negative, then plus minus. So when we multiply two positive numbers together, we get a positive outcome. Just like when we multiply two negative numbers together, the product is negative. The only way we would get a negative product is if one sign is opposite the other. So I'm looking in this region here, and in this region here. And then this is 2 by 4, so that area is 8. This is 3 by 5, so that area is 15. 8 plus 15 is 23. Actually, let me write the 8 and the 15 to show my work. So then we have 23 over 49. How many ways can a bug crawl from point A to point B along the segments in the figure at the right? Assume that the bug always moves up or to the right. I'm going to zoom in so that we can get a really good view of this. So if the bug starts at point A and wants to go to this point here, there's only this one path he can take. Similarly, if he wants to go to this point, he still only has the one path he can take. And then to get to the next point to the right, he still only has one path. To go to the next point over, again, only one path. And to go to that final point over, still only one path. If the bug were to move upwards, he would only have one way to get there, only one way to get there, and one way to get there. Because remember, he can't go to the right, up, and then to the left. He can only move up or to the right. So those are his only options, or its only options. So then, if the bug wanted to get here, it could move this way or this way. So it has two paths it could take. 1 plus 1 is 2. If the bug wanted to get to this point, it could go this path. It could go the orange path, or it could go the pink path. So we'd have 3 different ways to get to that point. 1 plus 2 is 3. And if we wanted to get to that point, there's one path, 2, 3, or 4 different ways to get to that point. 3 plus 1 is 4. So we can figure out how many paths by taking the sum of the two adjacent numbers. So the bug would have 56 different paths it could take to travel from point A to point B. A real number x is chosen randomly such that x will be bigger than 3 but smaller than 7. And y will be greater than 1 but smaller than 6. A quadrilateral, whose shape is that? What is the probability that the point chosen at random is at least 1 unit away from 4, 2? So that would be that point right there. So my center of this circle is at 4, 2. And 2 units away from 7, 6. So 2 units away from that endpoint there. So now just the shaded region inside the black rectangle is what we're looking for. So the black rectangle is 5 units high and 4 units across. So that's my total. And then my winning region would be that region, which is 20, minus this circle, whose radius is 1. So the radius squared times pi, I have to subtract that out. I also have to subtract out the quarter, the 90 over 360, which is the percentage of the larger circle, whose radius is 2. So then when I simplify this, I get 20 minus pi, minus, that's 1/4, and that's a 4. So then 4 cancels out over 20. So now I have 20 minus 2 pi divided by 20. I can take a 2, factor a 2 out of that numerator, and factor a 2 out of the denominator, 2 times 10. And then my solution, or the probability that it falls in the designated yellow shaded region, is 10 minus pi divided by 10.